I tell you that if you ignore Project Amber, you might not be able to read or write Java code sooner or later. Hi everyone, thanks for joining in the session today. So today I would be talking about Project Amber. What is it? Why do you need it? And how you can use it in your applications. And I would demo all the features using by live coding them, and I would be using minimal slides. And just in case, if you missed Usha's introduction, Usha introducing me in the chat, and if you're trying to Google who I am and what do I do apart from presenting at conferences like this, you can stop that now. I work as a developer advocate with JetBrains, and what that essentially means is that I help developers become a better version of themselves by using IntelliJ IDEA in the best possible manner. I'm also a Java champion, and I have authored a couple of books to help developers earn the Java certification, because I strongly believe that the certifications can help developers level up their programming skills. Right, so let's start with Project Amber. It was started in early 2017, around the same time when Java 9 was released and when Oracle moved to a 6-month release cadence for Java. And it's led by Brian Getz at Oracle. You can access this link to know everything about Project Amber. And let me simplify the purpose of Project Amber and all the text here for you. So Project Amber is not one big language feature that you can see in Java language. We are talking about an umbrella project which has multiple language features being worked on, like records, seal types, switch expressions, and many others. And as these language features are worked on, they are complete, and then they are released with a Java version, which we know as comes out in every 6 months now. Why should you care? Are you wondering, I really don't need to know about all these features because probably I might never use them. Think again. I'm talking about the Java language features and not API, which you can ignore. And even if you don't use all these features yourself, you might get to read the code written by someone else which uses all these features. For an example, think about lambdas and streams. Even if you have not written those in your code, you still get to read the code excuse me, written by others which use streams and lambda. So you just can't ignore it. For a quick example, let me show you quick slides which show how Project Amber has changed how you code in Java. With Java 10, var was introduced, and this can change how you define your local variables. Now, you may skip using the explicit types. With Java 12, you had a concise form of switch statements which make your code, which lets you return a value from the switch statements, which you couldn't do earlier. Sealed types released in Java 15 would let you model your business domain and restrict what other classes or interfaces can extend or implement your types. And this is one of my favorites, text blocks in Java 13. Let you enjoy working with long strings. You have all the joy minus all the pain. And in probably a future version of Java, you might be able to define methods like this, single line methods like lambdas. So I mentioned that where Project Amber has multiple language features under it. So are there any stages? Yes, they are. Oracle makes sure that every feature that goes into the language goes through multiple stages, and at each stage, it could see whether the feature is the right one to go into the language, because unlike APIs, which can be deprecated at a future time, language features cannot. So they go through multiple stages, and at any stage, it could be taken off and not allowed to go into the language. So in today's session, I would cover all these features which are a part of Project Amber. All these are language features. And let's start with the sealed types, which have been introduced in Java 15. Java 15 would be released this month on 15th of September. So let me go to my IDE. I'm using IntelliJ IDEA, the latest version, which is 2020.2, which supports Java 15. So why would you need seal type? So seal type is a preview language feature. I'll come to what a preview language feature is at the end of the session. So seal type is a preview language feature which restricts which other classes or interfaces can extend your type. And let's see why you would need it. Imagine you want to model the different type of plants that can be grown on this planet. It's a big responsibility, right? So let me get started by creating a new class. I would say I want to create a new class and name this class as plant. So what are the ways I can reuse the functionality of class plant by inheritance? I'm not talking about composition because that's a different topic to talk about. So let's say I create a couple of classes which extend my class plant. So let me, okay, so these are the classes which let's say I create to extend class plant. For your quick information, I just used live template in IntelliJ IDEA, which lets me insert a chunk of code if I type in a few characters. Excuse me, just let me take a sip of water. Right. And whenever I use any shortcut in the IDE, that would show up in the towards the bottom of the screen. Let me show you. Okay. So this, you can see something pops up on the bottom, which would help you understand the shortcut that I would be using throughout the session. I would not pause to kind of talk about the shortcuts which I would be using because the purpose is to show how things work and not really talk about the IntelliJ IDEA features. Great. So we're just talking about, these are the couple of classes which I can create to extend my class plant. And how would you usually use these types? So let me go back here and say I have a method, process type. And what I'm doing here is I'm passing a type of plant, and depending on what the type of that plant object or instance is, I'm calling certain methods like harvest cucumber or sow climber, depending on whether the plant is a cucumber or a climber or a herb or a shrub. That is all okay. We are okay to do that. What we really don't want is the else part, because I know that the plant class, which I define, has only 4 other classes which are extending it. So I should not be needing the else part, but I have to do that. And did you notice these the message? And this is from a real project which I came across. I'm not going to share where I read the message, but as developers, we write these messages. So this is something that a place that we don't want the control to reach to. But as a developer, I have no ways of controlling this part. The control can come to the else block if I have another class created by a junior developer which extends class plant. I have no way of restricting it. So let me go back to my plant class and let me define it a sealed class. And why would I want to do so? To model my business domain. I want to define, I want to create secure hierarchies in which I want to say that this is my class plant and I only want 4 other types to extend it. I don't want any other class to do that. How can I do that? Let me define this as a sealed type by using the reserved word sealed. Then I say permits, and I have to write in what all classes do I permit to extend it. Let's say herb, I say shrub, and then I say climber. Right. So that's not all. I also have to make sure that the classes that extend my plant class, they are either, let's say what IntelliJ is suggesting. I can use Alt Enter and see what suggestions it has. So I can make a class herb as final. I can make it as non-sealed, or I can make it as a seal type. If I make my extended class a seal type, I would have to again go through the same process. I would say it is a seal class and it permits another class, say cucumber, to extend it. And here I would need to make it either final, non-sealed, or sealed. So let's make it final. So how does that help? In a future version, Oracle is working on extending the switch expressions, which I would cover later in my session, where you would be able to switch on plant, instance of plant, and depending on what type is, you can call the relevant method. Now, in this case, you don't need to have a default case because the values that the type of instances that could be passed to variable plant would be exhaustive. So you get to decouple the accessibility from extensibility, and you can create secure hierarchies using this. So this is what the sealed classes could be used. Similarly, you could define sealed interfaces. So I've already written this code because there wouldn't be a lot of time to write all the code. So this is a sealed interface which permits other two interfaces to extend it. And the interfaces that extend it could be non-sealed or could be sealed. And when you say it's a sealed interface, you can also define which class implements it. Right, so I think that's what I have for the sealed types. So let me move to records. This is again one of my favorites. Records lets you define, model your data as data. It has offers you a compact syntax to do so. For a quick example, imagine you go to a shopping place and you want to buy trousers or pants for you. And what you see there is pants of all the same size. What do? Of course, you have to buy the pant which is the only size available. So depending on your own size, the size could be big, tight, or small for you. And if you're lucky enough, it could fit perfectly. So this is what we have been doing as developers to define our data classes. We have been using the regular classes to model our data as data. So let's go to the IDE again, and let me show you a class where I'm trying to, so this is a class where I want to define a class, a person. I want to encapsulate values like name and age by using a class, and the purpose is to write those values as to a text file. So let me go and define this class as a regular class. Right, so what can I do? I can say string name, and I could say int age. So this looks okay. Let me go back to my class, and this looks okay. I need to define a constructor here. So I could say insert a constructor with both these fields, and this looks okay, right? So this code is okay to go now, but we have been told that the values, the fields should be private, right? So let's make them private. So what do we do now? How do we access the values now? I need to insert the getters and setters for these methods. Perfect. So this looks good, but there is one problem. If I add this class to a collection class and then I try to retrieve the value back, it would compare the object references and not the values. So what do we do? Let me go down and insert equals and hash code methods for it. So let's see, I think we are done here as well. Only one method is left, which is the toString. So let me define that as well. Of course, the IDE can let you define everything here. What is the problem with the class? Even though the IDE can help you insert all the code that you need, or you could use other things like Lombok, what happens when anyone has to read it? The intention is not clear. So I still have to wade through all the code to figure out that this is a data class and not a regular Java class. So what are the options? A lot of programmers I have seen would make this final, not final, public, but then it would not be in alignment with the encapsulation principle that we know. That would not be a good thing to do. So what are the options with records? So let me go back to my class and let me delete it here. And instead of that, let me define a new class person, but this time I say this is a record. And here I can say string name and I can say int age. Now let me go back and see if this is working. Right. So I have now a compact form to define everything which I did in the last instance where I had all the getters, setters, toString, hash code and equals. Everything is provided here. So let me go back and see if I could actually write this object to my file and read it. So let me say I want to read write object. So, okay, so system cannot find the file. Haha, live demo, something has to go wrong, right? Okay, so it is building, something is happening, right? Hopefully we'll see some output soon. Right, it is working. Okay, why do I get this error all the time? Okay, let me take this off and let me go back to my class and let's run it now. Right, so it is running. It's taking a lot of time, which it should not. Bad idea to update your software right before a demo. Okay. So we get an error which says not serializable exception perfect. I need to go back to my person class and make sure that it implements the serializable interface, because as we know, if you want to serialize a value to text to a text file, that has to be serializable. So let's go back and run this class. Hopefully that runs now without errors. Good. Yes, you can do it. You can save it to the, yay! So we have the file, the value which has been saved to the text file, and we read it. Now let me go to the out folder and show that this file, this class, person class that we just created was a syntactic sugar, and behind the scenes, you can see that the compiler has created a full-fledged class, and as visible, you can see that it's a final field. So the data class that you just defined, it's shallowly immutable. Of course, if you're talking about objects being as fields, then depending on how you manipulate them, calling their methods, you can change the values. So that's why it's called shallowly immutable. Right. So what else do we want to do with the records? Let's see. Okay, so to use the records, you just saw that you just need to call it as a regular class. I'm calling the constructor. Of course, you can go back to the person class, and here you can insert another constructor. And I say if age is less than 0, I want to throw an error, and I want to say throw new illegal argument exception, and I say age cannot be less than 0. Right. I should have used the sign. That's funny. Okay, so this is how you can insert a constructor. Notice you don't have the parentheses here because it's a compact constructor. What else you can do? You cannot add fields to your records because the records would like it to be known or identified by the fields you have in its declaration. So you cannot add more. I cannot say int, let's say length or height. So this will not be allowed. Of course, if I make it a static field, that would be acceptable. I can add instance methods to it and static methods to it as well, but you really have to think whether you want all this in a record, or would you think a regular class would be a better fit there? Okay, what else can we do? I just showed you the decompiled class. We can also define generic records. So I have a class. So this is a generic record, which is parcel, and this is the parameter here. And I could also add annotations to it. Right. Okay. So this would, let's drop this part because I'm missing something in my configuration, I guess. Okay, so you can add annotations to your fields and you can define a generic record. Right, and I just showed you that you can serialize the records. Let's go back to the other feature that we have. Yes, so let's talk about pattern matching, for instance of, and what is it and how it helps. So let me go to my IDE again and show how you can use pattern matching. So this is a class, and let me use an instance of operator to figure out if this object is an instance of class string, and depending on whether it is, I would say string value is equal to, I need to cast it to the type string, cast my method parameter, and then I say just print out a value dot to uppercase. Right. So what is the problem here? So this is something that we all developers hate, because what I'm trying to do here is I'm trying to figure out whether object is an instance of string. Of course, if it is true, what else would I do apart from extracting some value or calling a method? But still, I need this line, which is redundant. So with pattern matching, for instance of, you can take it off by introducing a pattern variable. So let me just press Alt Enter here and replace this variable with pattern variable. So this variable is defined right after the type string, and now you no longer need that extra line of code, which is great. Though it might seem a bit simple here that we're just getting rid of one line of code. In the examples that I have on the next slides, you would see the real value of using pattern matching, for instance of. And what is the scope of this pattern variable? It is only accessible in the if clause. What happens, let's say, if I say else, and if I say a value, of course, IDE doesn't identify this variable because it is not accessible in the else part. I say, okay, is equal to, let's say, hello. What can I do now? Let's say I can create a local variable or I can create a field. In this case, what's happening is, even though this variable is accessible in else, this is not referring to the same variable which is in the if clause, in the if part of the statement. So that's a little bit of tricky part you need to take care of. Now, as I said, let me show you how you can use pattern matching for instance of to simplify your code bases. So let me go and show you how the programmers usually write the equals method. So this is something that you might have seen a lot of time. And right. So what can we do here? So let's first of all replace other with a pattern variable. And I could also go and say merge nested if. And what else can I do? I can simplify this. Now see how you could reduce just 6 to 7 lines of code with just 1 line of code. And it's still readable to me. So it's not just about making your code concise, but it's also about still making it readable. Let me show you another example. We need to go to method prod project, right? And here, let me simplify this code block to just a couple of lines, of course, making it simple but concise but simple to read. So let me go. So when you see that you have some highlights in IntelliJ IDEA, like this yellow background, you know that the editor has some suggestions for you, and you can see those suggestions by using Alt and Enter. So let me say Alt and Enter and replace child nodes with a pattern variable. Now I can go to the if statement, and you can see there are two if statements right one after the other. So I can merge these if statements by using, again, Alt and Enter. I say merge nested if. Now I have another instance of, and I can again use pattern matching for instance of. Why not? So this time, let me inline this variable. I say refactor my code and inline it. Again, I have two if statements, right, one after the other, and I think I can merge it again. Right. Now, how does this code look? To me, it looks concise and easy to read. So that's the beauty of using pattern matching for instance of. And with IntelliJ IDEA, we not only allow you to use the latest language features, but also update our existing inspections so that they work with the new features. And that's how you get to be a better developer and write better code. Right. So what is the next feature that we're going to cover? So that's text blocks, another one of my favorite features. With text blocks, it makes it easier for you to work with multi-line string values without all the clutter of ampersand, and the backslashes and the other characters that we use to negate the values which are not typically allowed in a string. But now, as we are working with more languages, we need to use them. So how can you work with strings with all the joy but none of the pain? Let's see. Let me go back to my editor and let me see where I have the class. Okay, so this, oh my God, I don't have any code here. Not a problem. So you can compare the strings with the kids. They're cute when they're small, but not when they grow old. Especially the teens are horrible. I hope the ones, the attendees, if you have teens as your children, God bless you. Okay, so let's start with, let's say, a string variable, and I'm going to keep it short. And let's say, I say I am still a small kid, and I am still good, and I am not so good now because I am growing. So I am growing. Now I have started to crawl. And what else can you do? Okay, so this now, as you see how as the string is growing, it becomes a bit difficult to read. Now I am in my teens. In my teens now. That's even horrible. Started to learn a new language. Started to learn a new language. So let me go and see if I have something and I could use some other language. Yes, I have. So let me insert this JSON value in my, yes. So, right. How does that look? How does the string look now? Looks nice and sweet and simple. No, it doesn't. No, it doesn't. How can you help it? How can you make it readable? Let's see if we can do something about it. Let me press Alt and Enter, and I can replace that with text block. Let's see how it turns out to be. Not so bad. Yes. So I still need to figure out couple of things, but it's still readable. And now, because I was just typing and not making sure that I'm taking care of all the new lines and other things, it seems a bit of messy now, but it really isn't. Text blocks are a charm to work with. Let me show you another example. So let me say this is a JSON value, and I create a text block using 3 double quotes. How much time do we have? 10 minutes, right? And now I can just copy paste the value which I had from my resources file. Now, do you think this looks much better to read and write? Because if I would not have been using a text block, then it would take a lot of pain to me to use backslashes to kind of negate the double quotes that we have in the string value, as we just saw in the previous example. And what else can you do? So the strings, the text blocks, they are regular strings. So compiler does a lot of heavy lifting for you. So they are still strings behind the scenes. You just get syntactic sugar so that it's easier for you to program it. And just notice the delimiters that we have. It's not just a single double quote, it's triple double quotes. What a tongue twister, right? Okay, but we still have 3 double quotes to start and end a text block. And where would you like to use it? Of course, use it anywhere where you think your strings are beginning to read more difficult. You can use it to code your queries, your SQL queries, your JSON values, and any other code that you have in any other language. So it would be simple to do that with a text block. And notice what happens to the incidental white spaces. Do you think this should be included in your string value or not? So when you see a vertical green string line here, so this is what tells you in IntelliJ IDEA that anything which is beyond this would be included in your text block. And let me move any value on the other side, and now you can see that the vertical line also moves. Now everything, now this is part of your data, and this is 2. So either you can move any of the values or you could move the delimiter, the closing delimiter. And one quick detail, to start a text block, you need to have one line break after the after the opening delimiter. So this will not work. You'll have to insert a line break here. And the other things with so text blocks are a standard feature in Java 16. They were introduced as a preview feature in Java 13. And the changes that were made to the preview feature to text blocks in later version was addition of \s so that you could insert any trailing spaces, because by default all the trailing spaces were trimmed. Now you can insert them explicitly, and you can also make sure that you whether you want to have all the lines on the new line or whether you don't want to have that. So you have another character to control that as well. The other one which I would quickly like to mention is that even I understand that a lot of you might not be using the latest Java versions like text blocks which came out in 13. So what you can do to benefit to ease how you work with, let's say, the JSON values or the SQL values in your strings. In IntelliJ IDEA, you can say that you want to inject language or reference. And let me say I want to inject JSON to it. So I can inject language reference in text blocks or in the regular strings in IntelliJ IDEA. And what happens with this is that you get code completion and recognition. So now if you see, see a red bar here which says a comma is missing from my JSON value. So this is the benefit that you get when you inject language or reference in your strings with IntelliJ IDEA. So we're done with the text blocks. And now let me go to switch expressions. So again, this is a standard language feature in Java 14. It was introduced in Java 12. Let me see what we have here. We're going low on time. Wow. So this is how you have been used to defining using a switch statement. You switch on values, you assign a value to a variable, then you have the break statement. I know it's verbose. We already have a solution for it. So now let me convert that to a switch expression, which is a concise form of switch statement. And you can also return a value from it, and you don't need the break statements. So the control doesn't fall through by default in the switch branches. I can replace that with a switch expressions with just one click here. Now you can see it is much more concise and simple to read and understand. And as you can see, you can return a value from the switch expression. I would not code the other parts where you can define a block of code for each branch, but you still need to make sure if you are using it to return a value that a block returns a value. So let me quickly go to the other parts, which is the local variable type inference with var. I think Simon Ritter covered local variables with var in today's one of the session today. So I would not go a lot into the details since we are low on time. Let me just simply zoom through it. Okay, so quickly, before I dive into what the details are, if I give you this puzzle and if I ask you which is the right piece that goes in, it would be great if you could type in your answers in the chat window. Do you think this piece would go in here? So that's the answer number 1. Do you think this piece fits in, or do you think this piece fits in? If you typed in 3, you are absolutely right, because and this is how type inference with var works in Java. You give the compiler all the context, and then you let the compiler reduce the work for you. The compiler has all the information to figure out what the type of your variable is, and then you can easily drop the explicit type and define your local variables using var. So it's a win-win situation for all. Write less code, but the compiler and that compiler is happy too. So instead of defining local variables like this, you can drop the explicit type and define them like this. What are the benefits? It's concise, it's easier for you to write and code. Less code, easier to read and understand. But as I said, you need to give the compiler the context on which defining the variables. If you do not assign a value to it, or if you let it be unassigned, that will not help, because the compiler would not know if instead of showing the bigger picture, I just give you the smaller pieces of the puzzle and I just ask you, so where do you think this piece would fit in? Would you know the answer? No, you wouldn't. So that happens with the compiler as well, because Java is still a statically typed language. Behind the scenes, the compiler knows all the data types, and it's not for the runtime to figure out and go into that puzzle mode every time to figure out what the data is, the data type is. And it's not just chopping out that explicit type. We are talking about giving all the information to the compiler. So you just can't chop away the type here in the array declaration and let the compiler figure out everything. That will not work. You can use local variable type inference with var where at all these places, including instance initializer block and static initializer block. I would upload the slide somewhere and share the link so that you have access to all this. One last thing on this, just in case, if you have to figure out what the type of the variable a letter 2 is, you could use var easily, because the compiler would know what the return type would be after you have a chain of methods calling on a variable. So that's a good place to use var. One last question. What do you think is the answer of this quick question? Type your answers in the chat window. Do you think it's 2, 2.5, 2, 2.5? Oh no. If you even have to invest 1 second to figure out, you should be using var, because the answer is 2 and not 2.5. The compiler always knew the answer, and as programmers, we are the ones who crib. No, this should not have been this way or that way. No, but the compiler was always clear that when you are dividing an int by int, the answer would be an int and not be a double. So again, another a few benefit of using var there. So the last feature that I want to cover is local variable type syntax for Lambda parameters, which came in Java 11. So let me go back to my editor. Why did I do so and not have just the slide? Because I'm running out of time. Yay! Right. So this is how you have been defining your Lambda functions, Lambdas. So again, the compiler is already smart enough to figure out that this is an integer because you already specified this here. Now, what you can do is, let me say, this is another way of specifying your lambdas. Cool. What else can I do with it? I can say that this is an integer. Cool, good enough. What can I do with it? I can say, I can use var instead of writing it as integers. So these are not different types of lambdas. This is just the way I'm writing it. All are the same. Here I let the compiler in for the type. Here I let the compiler in for the type again. I do not include the brackets because I know the compiler is smart enough to know that as well. Here I'm specifying the type even though that is not required. Now in Java 11, I am able to use var because I want it to align to the usage of var with the local variables. Probably they were feeling a little jealous that they are not allowed to use var. What are the benefits do you have? you can add a not null parameter, which is not working for me. I'm so sorry about that. I don't know. I have this issue every time. But yes, you can do that. Okay, so now let me go back to my presentation. Where is it? Oh my God, did I miss it? Did I? Okay, right. In a future version, we're running out of time, already 5 minutes. Okay. In a future version, you could define concise method bodies. If you have a method like this, a single line method, you could define it like this. Looks familiar, right? Last section of the presentation, what are the preview language features I've been talking about? There are a lot of preview language features which I covered in the presentation. What they are. So a preview language feature is not an incomplete feature. That's a feature which is absolutely complete and ready to go, but we are talking about an impermanent feature. And why is Oracle doing that? Because unlike the previous releases, which had a difference of around 3 years, 2 to 3 years between every release, like Java 8 to 9, now we have a new release every 6 months. So it would be good to have developers like you share your feedback on the new features before they could be made permanent in the language. So this is Brian's tweet, which I mentioned, who leads the project Amber. And he says that he is looking for feedback from the developers, and Oracle does take the feedback seriously because some time back switch expressions were changed. Initially, they were using the break statement or the break keyword to return a value from a switch branch, but now it has been changed to yield because a lot of developers complain that it is confusing them because break is already being used at a couple of other places for different reasons. So I asked Brian when would be the best time to submit the feedback. So he mentioned there are no hard deadlines, but the train as soon as possible. Right. So he said the earlier the better. So if you are, so I encourage you to try out the preview language features which are there in Java. And if you think there is some problem, share it with the team and be the change that you want to see.